Hello, class ninth. So, we have been studying chapter number 9, which is the most important chapter. Yes, chapter number 6, chapter number 8, chapter number 9, and chapter number 2, 3, 4. They are the most important chapter. Yes, they are the most important chapter. So today we are going to study about the inertia. Yes, today we will study about inertia. Okay, so kids, this topic is not so difficult. Okay, this topic is not so difficult, it's a very easy topic, and we have already studied about the inertia in previous class, and we also studied what is Newton's first law with a lot of example. Yes, we studied about them. So let's revise this topic. First of all, we will revise it. Um, First of all, no, let's do something different. Let's study this topic. Okay, let's study this topic, inertia and mass. Means, what is the relation between inertia and mass? What is the relation between inertia and mass? Okay, let's try to understand. Okay, let's try to understand. Okay, suppose if I say you have to push the train. Suppose if I say you have to push the train, can you push the train? Can you push the bullet? Can you push the metro? No, not. You cannot push them. Yes, it's difficult, it's impossible. Why? Because heavy force required to push them. Can you push the table? Yes, you can easily push the table because less force is required to push them. And you know what is inertia? What is inertia? Inertia is the property of a of on a inertia is the property of an object. Inertia is the property of an object, and according to this, that a body at rest continue to be at rest, and a body in motion continue to be in motion. Yes, a body at rest continue to be at rest, and a body in motion continue to be in motion. This property of a body is called inertia. And so what is the relation between inertia and mass? Yes, inertia and mass both are related to each other. Yes, the mass of a body is a measure of its inertia. The mass of a body is actually the measure of its inertia. Yes, the mass of a body is measurement of inertia. Yes, so inertia tells us about the mass. Inertia tells us about the mass. Okay, so the inertia of a body is measured by the magnitude of force required to change the state of the body. Yes, inertia can be measured by the magnitude of the force. Yes, okay, so inertia can be measured by the magnitude of a force that required to change in state of a body. So the mass of body is a measure of its inertia. Okay, inertia tells about the mass. Okay, and so the force required to change the state of heavier body is more than the force required to change the state of lighter body. This is because the mass of the heavier body is more than the mass of the lighter body. Okay, let me explain you in a simple language. Let me explain you in a simple language. Mm, if I say you have to push the train, can you push? No, you cannot. Why? Because it has more inertia. It has more inertia. When if it means what? Because as I said, inertia and mass both are related to each other. When the inertia is more, then mass will also be more. When inertia is more, mass will also be more. Inertia is more means what? Inertia is more means the body will remain in the state of rest, or it will remain in the motion. So you cannot push the train because it is in rest position, and you are trying to push, but it is not moving because it has more inertia. When the inertia is more, then mass is more, so it has more mass. So you need more force. You will have to apply a force of higher magnitude to change the state of body. Yes. So as I said that inertia of a body is measured by magnitude of force. So if higher magnitude will become, then inertia will also become higher. Yes. So and if higher less magnitude will become, then inertia will become low. If I say to push the door, can you push easily? Yes, you can easily push. You can easily push the door. Why? The reason behind it, uh, because it has less inertia. When there will be less inertia, there will be less mass. So you need less magnitude of force to push. So easily can measure by this inertia. So we need less inertia because it can easily move. So the you can easily push the door. Okay, I hope you understood the meaning. Now let's revise whatever is studied in previous class. We studied Galileo experiment of motion of an object. Yes, for an inclined plane. Yes, we studied about the Galileo experiment of motion of an object for an inclined plane. Yes, according to this, when a ball rolled over an inclined plane, its velocity increases, and when it goes up on the second inclined plane, its velocity decreases. If the inclination of both planes are equal, then the marble will reach to the same height which it rolled down. Yes, if the inclination of the second plane is decreased, it will travel to roll down. It will travel more distance to reach the original height. If the inclination of the second plane is made horizontal, the marble will travel forever trying to reach the same height. So, what is Newton's first law of motion? What is Newton's first law of motion? According to this, an object remains in a state of rest or in a uniform motion in a straight line unless compelled to change that state by an applied force. Okay, and inertia you already know. Then inertia is the natural tendency of an object to remain in a state of rest or in a uniform motion is called inertia. And in last class, in previous class, we discussed the many example of inertia, like if a striker hit a pile of coin, if a striker hit a pile of coin on a carom board, then the lowest coin moves out. Yes, and due to inertia of rest, the other coin will fall down. Yes, and if a coin placed on a playing cardboard over a tumbler is flicked with a finger due to inertia of rest, the coin will force down into the tumbler. When we travel in a car or driver, when the car driver applies the brake, suddenly we tend to fall due to the inertia of motion. Yes, when we are standing in a bus and the bus begin to move, suddenly we tend to fall backward because our feet in contact with the floor that is actually moving. So our legs are also with the in motion. So the upper part of the body, but the upper part of the body continue to remain at rest due to inertia of rest. Okay, I hope you understood. Now, guys, let's discuss a topic which is momentum of body. Yes, let's move on the next point. Okay, it's momentum of a body. So why are we discussing this topic? We are discussing this topic because momentum of body. This topic will help to understand second law of motion. Yes, Newton's second law of motion can be understood by momentum of body. So uh, momentum of any body is denoted by P. Yes, P is the symbol for momentum. Check out the spelling of momentum, momentum. So the momentum of a body is the product of its mass and velocity. Yes, what is What is momentum? Momentum is equal to mass into velocity. Yes, momentum is equal to mass multiplied by velocity. Yes, so the momentum of any object will be the product of mass and velocity. Yes, so uh, if the mass of any object is m and suppose its velocity is v, then momentum will be equal to p is equal to m into v, means p is equal to mv. Yes, this is the formula of momentum of any body, momentum of any object. This is the formula, p is equal to mv, where p means what? P means momentum of the body, m is the mass of the body, v is the velocity of the body. Okay, so now suppose that so a body is at rest. Suppose a car is at rest, then what will be its velocity? Definitely the velocity will become zero. Yes, definitely the velocity will become zero. If the velocity is zero, then what will be the momentum? The momentum will also become zero. Suppose there is a car whose the weight of car is 100 kg. Okay, so in the place of m, we will write 100, because 100 kg is actually mass. Yes, there is a difference between mass and weight. Mass and weight both are not same. Kids, remember, mass and weight both are not same, both are different. Okay, so they suppose the 100 kg is the mass of any body, and its velocity is 0, then we will multiply 100 with 0 by putting the value in the formula p is equal to mv. We will get the value of momentum in 0. So if the velocity is 0, then momentum will also be 0. But if the velocity is producing, then momentum will also be produced. Okay, what is the unit of momentum? What is the SI unit of momentum? Yes, SI unit of momentum. What is the SI unit? Well, the unit of mass is kilogram, we know, and um, the unit of velocity is meter per second. So the unit of momentum will become kilogram into meter per second. Yes, so the unit of so the SI unit of momentum is kilogram meter per second. Kilogram meter per second, or you can say kilogram meter second inverse. It is also the correct unit. Okay, so let me give you one example. Okay, suppose you have a gun. Suppose you have a gun and you fire the gun. Okay, you fire the, you know that the mass of bullet will is small. Yes, the mass of bullet is small. So when you will fire from a gun, it can still kill the people. It can still kill the people. Why it can kill the people? Because it has large velocity. When the large velocity will because the velocity is more, that's why momentum will be more. Yes, yes, large mass can be fixed, mass can be low, high, but velocity, it's the point. Velocity matters. Velocity matters. Yes, when the velocity increase, then momentum will also increase. So when you shoot from a gun, that time the velocity of the gun, that time the velocity of the bullet increase. Because of large velocity of bullet, momentum will increase, so it can easily kill the person. So the impact of a body depends upon its mass and velocity. Yes, it's depend upon the mass and velocity. Okay, remember this example. And uh, one more example, as you can see on your screen. Yes, as you can see on your screen, there is one example. Okay, so suppose you are driving a truck. Yes, truck. You are driving a truck. The speed of truck is very low. Okay, truck is moving at very low speed. Okay, uh, but speed of truck is low, but still the truck can kill any person standing in the front of it or standing in its path. Yes, why? Because the mass is high. Yes, because the mass of the truck is very high in comparison to the human being who is standing, in comparison to the person who is standing in the path. So the mass of the truck is very high. so the momentum will increase automatically. So a truck moving at a very low speed can also kill a person because of heavy mass of the truck. So momentum depend upon mass and velocity. If velocity can increase, then momentum will increase. If mass will increase, then momentum will also increase. Yes, so it's depend on kilogram meter per second. Yes, and also depend upon the time. Yes, also depend upon the time, that at what speed, in what time, the at what velocity, the in what second it is moving. Yes, suppose the velocity of a any object is very fast uh, with respect to time, then it can easily kill. Yes, but it has a heavy mass, then can it also will move, it will have more momentum. I hope you understood about the topic momentum of body. Okay, now let's study the law of motion, which is Newton's second law of motion. Let's move on the next point. Okay, so let's study Newton's second law of motion. So Newton's second law of motion is also very important. Yes, okay. Newton's second law of motion is very important. Okay, uh, okay, and according to this law, according to this law, uh, the rate of change of momentum of an object is proportional to the applied force in the direction of force. Yes, what is Newton's second law of motion? According to Newton's second law of motion states that Newton's second law of motion states that the rate of change of momentum, the rate of change of momentum of an object is directly proportional to the applied force and in the direction of force. Yes, suppose that there is an object who is moving with initial velocity u, okay, and its mass is m. Now after some time, due to acceleration, its velocity become v in t time. After t time, its velocity is v, and because of applying force f. Yes, when we applying the accelerator, we are actually applying the mechanical force. So because of it, because of f force in t time, the velocity from u, the velocity from u change to v. Yes, means the velocity of increase, but the mass is fixed. So uh, what according to this law, if we prove mathematically, suppose that in the beginning, when the initial velocity of the uh, object is u and mass is m, okay, that time the initial momentum, what will be, the suppose the initial momentum is p1, and when after applying f force, and the velocity become v in t time due to acceleration, and the momentum will become p2. Suppose the momentum become p2, so p1 is equal to mu and p2 is equal to mv, because m is the mass and u is the initial velocity, and for final momentum will become p2. Yes, so we got here two momentum. Okay, so according to this law, the rate of change in momentum, yes, whenever we are talking rate of change in momentum, whenever we use the word rate, it means we are talking with respect to time. We are talking with respect to time. And change of momentum, whenever we are talking about the change of momentum, it means we will subtract, we will uh, we will do subtract from final minus initial. So here final momentum is p2 and initial momentum is p1. So the rate of change of momentum will become p2 minus p1. P2 minus p1 means mv minus mu, mv minus mu. So here m is common, here m is common, so we will take out m. So the uh, formula will become p2 minus p1 is equal to m v minus u, m equal to v minus u. Yes, and if we talk about rate of change of momentum, in with respect to rate of change of momentum, we can say that m in p2 minus p1 is equal to m into v minus u upon t, and p2 minus p1 is equal to m into v minus u upon t, m into v minus u um, in the bracket divided by t. Okay, because as I said, this is the rate of change of momentum, so we got the value of rate of change of momentum. What is the value of rate of change of momentum? M into in bracket v minus u upon t. So the rate of change of momentum is always proportional to the applied force. Yes, applied force. Applied force, suppose that applied force is F, then both will be proportional to each other. Then we can write F directly proportional to m into v minus u upon t. F directly proportional to m into v minus u upon t. Okay, if we want to remove the sign of proportional, we will use the sign of equal. So in the and whenever we write the sign of equal, we use a constant whose value is always fixed. So it will become F is equal to k in m into v minus u upon t, where k is actually a constant of proportionality, Okay, now suppose that the value of k, now suppose that because we already know that what is acceleration. We already know in previous chapter we studied what is acceleration. Acceleration is equal to v minus u upon t. Acceleration is equal to v minus u upon t. So in the place of v minus u upon t, we will write a. Then the formula will become F is equal to kma. F is equal to kma. And suppose the value of k is 1, because k is the constant of proportionality. So here its value is 1. So when we will put in the place of k is equal to 1, then the formula will become F is equal to ma. Yes, which is showing that the rate of change in momentum of an object is proportional to the applied force. Yes, F is equal to ma. F is equal to ma is the formula of force. F is equal to ma is also the formula of force, where if we talk about the unit of here, then unit of force will become what will be the unit? Because we know that the unit of force is Newton. We know that the unit of force is Newton denoted by capital N. We know that the unit of force is Newton denoted by capital N. But if we can, by using the formula F is equal to ma, we can tell one more SI unit, because we know that the unit of m means mass, the unit of m means mass is kilogram, and the unit of acceleration is meter per second square. So the unit of F force will become kilogram meter per second square, kilogram meter per second square, or you can say kilogram meter second inverse square. Yes. So I hope you understood. So Newton's second law, according to this law, the rate of change of momentum of an object is proportional to the applied force in the direction of force. Yes, the rate of change in momentum. Rate of change in momentum means m into v minus u upon t. Yes, whenever we talk about the momentum, we will use mass also, m, because we know p is equal to mv. And rate, we will use time, because momentum is changing with respect to time. So it will be proportional to force F. So we can say if the force increase, momentum will also increase. Okay, if the force decrease, then momentum will also decrease. Okay, I hope you understood. Okay, it means what? Because in a previous slide we talked that when if the truck is moving slow, it can still kill the people. Yes, why? Because the force is applying more, because it has more mass. So when will be the more mass, there will be more inertia. And as you know that inertia is measured by the magnitude of force. Inertia is measured by the magnitude of force. Yes. So that's why the truck can kill the people. Okay. I hope you understood. Now let's move on the next point. Okay, it's time to ask question from you. Question number one: what is momentum? What is momentum? Right, it's unit. Yes, what is momentum? Right, it's a unit. So the momentum of any body is the product of its mass and velocity. Yes, the momentum of an object is multiplication of mass and velocity. Yes, so suppose the a body which is moving whose velocity is v and mass is m, then momentum will become p, means p is equal to m into v. Yes, momentum is equal to mass multiplied by velocity. Okay, where p is momentum, m is mass, v is velocity. Okay, and if we talk about the unit of SI unit of momentum, the SI unit of momentum is kilogram meter per second. The SI unit of momentum is kilogram meter per second, or you can say kilogram meter second inverse. Okay, suppose a body is at rest and its velocity is 0, then its momentum is also 0. But if the body is moving, then its velocity also change. Yes, there will be the value of velocity also, then momentum will increase automatically because of mass and velocity. When we multiply, then we get the actual momentum. That's why when the momentum increase, then what happens? Uh, Momentum increment depend upon the mass and velocity. Yes, that's why if the mass of truck, very heavy, so if it is moving slow, then still it can kill the person. Yes, if suppose a truck is moving, it can easily kill a person. Why? Because we know the mass is heavy, it is moving slow, means its velocity is slow. But it doesn't matter, because of mass and velocity the momentum will increase. When the momentum will increase, it will kill the person standing in the path because of the heavy mass of the truck. Question number 2: explain Newton's second law of motion with example. Yes, Newton's second law of motion. So Newton's second law of motion states that the rate of change in uh, momentum of an object, the rate of change in momentum of an object. Suppose the momentum is changing of in if any object, then the momentum, changed momentum at any time, or will always be equal to applied force. Yes, because momentum is changing because of when we are applying the force. Yes, suppose if the mass of any object is m, and it is moving a straight line with initial velocity u, and now it is due to acceleration, its velocity become v and time become t by applying force f, then we can say that momentum will equal to rate of change. The rate of change in momentum will equal to p2 minus p1 is equal to m into v minus u upon t. P2 minus p1 is equal to m into v minus u upon t. When we will put the value of v minus u upon t, which is equal to a, and rate of change of momentum is equal to always proportional to f, then it will become f directly proportional to m into v minus u upon t, and we can also write f directly proportional to m into a, or when we will write the constant, then proportional sign will be removed and it will become f is equal to kma. K is equal to constant of proportionality, so we can say f is equal to ma when we will put in the place of k 1. K is equal to 1, then the formula will become f is equal to ma, and the unit of force is Newton. The one example of Newton's second law of motion is when you try to catch the momentum. How do you catch the ball? When you try to catch the ball, because when a player shot the ball, then the ball goes very fast. Yes, if you are catching the ball that coming to you, you will have to draw your hand back. Why? Because the momentum of the body is very fast, and it's coming with high velocity. So when you will draw your hands back while catching, you are actually decreasing the momentum. You are actually decreasing the momentum by decreasing the velocity of the ball, because we know that mass of the coming ball towards you is very less. The mass of the ball is low, but the velocity is very high. So because when the velocity here is high, momentum also high. So when you try to catch the ball, you also move your hands back because you want to decrease the velocity so you can easily catch. Yes, this is the example of Newton's second law of motion. So it will save you from injury. Question number 3. How is mass and inertia related to each other? How to measure inertia of body? Well, mass and inertia are related to each other. We know what is inertia. Yes. So the inertia of a body is measured by the magnitude of force required to change the state of the body. Yes, inertia of any object is measured by magnitude of the force. Yes, the inertia and mass are related to each other. When the inertia increase, mass also increase. So the mass of the body is measure of its inertia. Yes, the mass of the body is actually the measurement of inertia. Yes, so because the train has heavy inertia, so it has heavy mass. The table has low inertia, that's why it has low mass, so we can easily push it. I hope you understood. Now we will meet in next class. We will study the third law of motion. Okay, and we will study about little bit about momentum again. Okay, we'll meet in next class. Till then, bye bye.